In this video, I'm going to introduce you to the method of iteration. We're going to start off by solving an equation that we already have a method to, or two methods to solve. This is a simple quadratic. We can't factorise it, but we could obviously use the quadratic formula or completing the square. But we're not going to. We're going to use the method of iteration, which we can then use to solve other equations that we couldn't solve by other methods. So we're going to start off by rearranging the equation in various ways to make x to have an x on the left hand side. So one way we could do that would be to say, okay, x squared is equal to 2x plus 6, so x is the square root of 2x plus 6. Okay, so that's one way. Another way, we could start off with the same first line, so x squared is 2x plus 6, and then we could divide through by x this time, so we'll have x is 2x over x plus 6 over x, so that's obviously 2 plus 6 over x, that's the second way. And then a third way, we could say that 2x is equal to x squared minus 6, so x is a half of x squared minus 6. Okay, so those are three different rearrangements of the same equation. So we're going to then use each of those in turn with the method of iteration. So what we do is we start off by guessing a solution, and then we use that solution by feeding it into the iterative formula. We generate a sequence of numbers that hopefully lead us towards a solution. So we start off with an x1, we put that into the iterative equation to give us an answer for x2. Okay, we then use our x2 to generate an x3, and so on. So basically what we're going to do is we're going to say that our xn is going to be used in the iterative equation to find the next term, xn plus 1. So I happen to know that the quadratic looks like this, and one of the solutions is between 3 and 4. So it makes sense to me to start off with our x1 term being 3. Okay, so x2 is going to be the square root of 2 times x1, which is 3, plus 6. So that will be the square root of 12, which is 3.4641 to 4 decimal places. So then to generate x3, we're going to put in that answer, so 2 times 3.4641 plus 6, obviously I'll keep the full accuracy in my calculator, square root that answer, and we get 3.5956. Now, obviously, the ANS button on your calculator is very useful at this stage. So if you want to generate this sequence, if you just put 3 equals, or xe, and then use the formula square root of 2 ANS plus 6, put brackets around that, and then just keep pressing equals, you'll generate the sequence. So we can do that to find x4, which is 3.6320, and then we can keep pressing equals, and eventually our sequence stabilises at x equals 3.6457 to 4 decimal places. So if we use a similar method with the second rearrangement, so we're going to say that our xn, if we put into this formula, will give us xn plus 1. So we'll use the same starting point, so we'll have x1 equals 3. So x2 this time is going to be 2 plus 6 over 3, which gives us 4. Our x3 is going to be 2 plus 6 over 4, which gives us 3.5. x4 is going to be 2 plus 6 over 3.5, which gives us 3.7143. Keep pressing and pressing, and again we get the same solution to 4 decimal places of 3.4657. Okay, and this is our third arrangement, so if we add our suffixes here, so we've got xn here and xn plus 1, so this time the formula is a half of the previous answer squared minus 6. So let's start again with x equals 3 and see what happens this time. So x1 equals 3, x2 is going to be a half of 3 squared minus 6, which is 1.5. x3 is going to be a half of 1.5 squared minus 6, which gives us minus 1.875. x4 is going to be minus 1.242, and then x5 is minus 2.2285. Now this sequence is not converging. If you keep pressing equals, you'll find that it's just actually a divergent sequence, so this time we don't actually lead to the solution. Okay, so let's have a look at this question. First thing we need to do is to find the solution to 4 decimal places. And we're given a starting value. You're normally given a starting value in, I'd like to say always given a starting value in these questions. So we're going to start with x1 equals 1. And then we're going to generate the first few terms of the sequence and then just keep pressing equals to get the solution. So x2 is going to be 2 lots of 1 cubed plus 10 over 3 lots of 1 squared. Okay, so that gives us 12 over 3 or 4. I'm going to use that now to get x3. So we've got 2 lots of 4 cubed plus 10 over 3 lots of 4 squared. Okay, so that gives us 4 cubed is 64, 2 lots of it's 128, 138 over 3 lots of 16, 48, and that is 2.875. Okay, so we're going to then feed that in. Won't bother to write it all out this time, but we get 2.3199. Okay, keep pressing the equals key, and we end up with x equals 2.1544. Okay, so look at part B. So find in the form fx equals 0 the equation that the iterative formula solves. So how we go about that is to say, okay, if x equals 2x cubed plus 10 over 3x squared, we can multiply both sides by 3x squared, so we get 3x cubed equals 2x cubed plus 10. Taking the 2x cubed to the other side, we've got x cubed equals 10. So what we're actually doing in the first part is solving the equation x cubed equals 10. We didn't really know we were doing that. So does it make sense? So what is the cube root of 10? Yep, it is 2.1544 to 4 decimal places, so that does make sense.